Well, good afternoon to all of you. My name is Christina Richards, and I'm the Vice President of Marketing for AOptix. And today I'd like for us to talk together about the year 2020 and what our networks are going to look like at that point in time. And things we can do in the way we build out our networks today to prepare for that. But really quick, before we start looking to the future, let's take a quick look at the past to put things in perspective. Does anybody remember this phone? Yeah, I see a few nods. Okay, did anybody own this phone? A few people would admit to it. The rest of you guys, you know who you are. So I put this picture up here to remind us of a couple things. First, to remind us of how far we've come in the last 30 years when, in 1985, this was state-of-the-art technology. But more importantly, to point out that in the year 2020, we're going to look at our networks today in 2015 kind of the same way today we look at this phone. And that's just 5 years from now. What I mean is that the growth in capacity and applications and complexity of our networks is going to grow so exponentially that it's only going to take us 5 more years to eclipse everything we've done in the last 30 years. That puts it in perspective, and it also lets us know that we have a big challenge ahead of us as a wireless industry. So now let's talk about the future. In 2020, the Olympics will be held in Tokyo, Japan. And this is the location where a lot of people expect to see the first major implementations of 5G networks. We'll see little pockets of 5G prior to that, but this will be one of the first times that we really see it on a large scale. It's kind of interesting historically because in 1964, that was the last time they held the Olympics in Tokyo. And that was the first time we ever had live satellite transmission of television of the opening ceremonies in color from Tokyo to the US. So Tokyo has a precedent for putting out groundbreaking technologies in this event. And I think it's going to be a very exciting time. Now, if we kind of imagine ourselves standing inside of that beautiful stadium in 2020, what kind of things will we see at that point in time? We probably see 1-second downloads of ultra-high definition video straight to our mobile device and a virtual screen on which to watch it. We could potentially see holographic imagery or a 3D projection of the nightly news. Now, let's think about what that might be like for a minute. We're standing in that stadium, maybe we have our 5-year-old kid next to us, and we're pulling up on our device a hologram of an Olympic athlete that we just saw compete in one of the events, and we can interact with them. I think it's some amazing technology that 5G is going to drive, and one of my other favorites is this idea. This is an instant translation glass. So global visitors can put this glass on at the Olympics and look at any block of Japanese text and have it immediately translated into their native language. I think this is really cool because I am a huge Star Trek fan, and I don't know if any of you guys are, but in Star Trek they have something called the Universal Translator. And I think this is getting really darn close to that Universal Translator. So it's a piece of science fiction that I'm really looking forward to seeing turned into science fact. All of those things, particularly the Google Glass, or the translation glass rather, are part of a larger group of things that we now call the Internet of Things. And you guys are probably familiar with this term by this point in time. And the Internet of Things refers to a collection of devices and sensors and embedded chips in and on everything that connects together a whole bunch of information to create a full internet, a full communication structure. We expect that in 2020, the Internet of Things will reach its critical mass. And by doing so, it will generate an intelligence in the cloud from which we can gather information that we can't use today. And that will be because we'll have inexpensive sensors embedded in and on everything, pulling information from what we do on a daily basis and pulling it up into the cloud. And this will deliver new value to us as end users, both in terms of health and safety, convenience, and probably things that we can't really even imagine just yet. The Internet of Things includes a vision of the future where we have things like the connected car, health monitoring equipment that could provide life-saving information, or even something as mundane as a vending machine that can message back to headquarters to let them know their stock is low. It will travel over both wireless and wired networks, but most of the traffic will go over the wireless network, and that's why it's going to be so important for us to develop the 5G wireless network that can drive that Internet of Things. Now today, the Internet of Things is in its nascent stages. We're starting to see devices that we're using currently, and right now we can support them using current 4G networks, also helped with Wi-Fi offload. But in the future, we're going to have a traffic volume that's completely unmanageable by the end of the decade. Even though each of those little sensors has just a small amount of data, when you get the quantity that we'll be looking at by 2020, you start to have a very real problem in terms of how you manage your network. And if we want to maintain the quality of experience for our end users, then we have to move forward, we have to build out 5G. Even today in 2015, we're currently at 7.1 billion mobile connections. 7.1 billion. Now, these next three data points talk about the volumes of data that are generated by some applications that you guys might be familiar with, Twitter and YouTube and Instagram. But I want to ask you guys a question. You see these data points? Do you think that these are per month, maybe per week, per year? Anybody have an opinion? Just shout it out. Per day? It's actually every minute. You were right. Every minute we get 500,000 tweets. Every minute we get 5 million videos. Every minute 70,000 photos uploaded onto Instagram. That's today. That's today in 2015. So when we look at 2020, now it's not 7.1 billion mobile connections anymore. Now it's 11.5. This will be more connections than there will be humans on the Earth. And if we think about that, it kind of makes sense because now we're talking about the Internet of Things. The Internet of Things doesn't just connect people anymore. It connects people with machines and machines with machines. So that means over 25 billion new machine-to-machine connections that are driving this network that's happening in 2020. That'll drive $4 trillion worth of revenue opportunity, as well as 50 trillion gigabits worth of data per minute. Per minute. Most of you have probably read the Cisco VNI report that talks about the exabyte era and what we can expect to see in terms of mobile data usage by 2020. And if you divide it out by minute, that's what you get, 5 trillion. We obviously need some revolutionary new technologies in general, but certainly a new network backbone that will be able to handle this kind of capacity demand. And to do that, we really need to look at 5G. Now, 5G we've talked a lot about in this conference already. And as you guys know, the standards aren't quite there yet in terms of what 5G will be precisely, but we have heard several goals laid out by 5GPP, the standards body, on what the goals are for 5G. It really boils down to two things. More bandwidth, less latency. Those are the key things. And there's a couple ways things that we have to do to be able to make those things a reality. So network capacity, one of the goals is to connect 100 billion devices. Now, to be able to connect that many devices, we need a network that is 10,000 times greater in terms of traffic capacity than the network we have today. That's over the next 5 years. Also, cost and power will be an incredibly important thing to focus on because we're going to need ultra-low cost machine-to-machine connections with these embedded chips and sensors. And all of our devices, not just the chips and the sensors, but our devices themselves will need to have significantly less energy consumption to be able to drive this network. Data rates. So the expectations, the goal right now is 100 megabits general end user data rate. So with a 10 gigabit peak end user data rate option. That's a lot per user. 10 gigabits per user, but you need it when you're talking about applications like ultra high definition video. And you can imagine the kind of network that type of data rate is going to require. Latency is also going to be very important. We'll need less than 1 millisecond latency for certain applications, not in all applications, but that's a significant difference from our latency rates of today, which is in the range of 50 milliseconds. But you need it for things like emergency services, remote surgery, autonomous self-controlled cars. And so these things together really kind of pull together the goals for 5G for the 5G wireless network. Now, to get there, to achieve those goals, obviously we need a lot of new technologies. And we've already talked today in this conference, both today and yesterday, about some of those. We've talked about radio access technologies and some of the other sessions. So in this one, I want specifically to talk about backhaul. That's het networks and backhaul. So we're going to talk about backhaul here today. And I'm going to talk about, in particular, technologies that incorporate millimeter wave in various ways. I'm going to talk about short-range millimeter wave and laser radio technology. So on the short-range millimeter wave side, there's been some recent advancements this summer in Texas, in Austin actually. There was a prototype demonstration of 10 gigabits over 200 meters in the E-band range. And that, of course, is 10 times more bandwidth than 4G cellular bands, but over very short distances, 200 meters. But beamwidth is inversely proportional to frequency. So as we start going up into these higher frequency bands, we're talking about millimeter wave, we start to have to consider trade-offs between short-range broadcast applications versus long-range directional applications. There's another technology I want to let you guys know about as well, and that's laser radio technology. This one also has had some recent developments. There's already a 2 gig version of laser radio out on the market, but recently we've demonstrated 10 gigabits also in the E-band using 128 QAM modulation and 40 gigs on the optical side of the product. So laser radio is a combined product between optical and advanced optics. And that, of course, would give you 40 times more bandwidth than 4G cellular bands. So now we're talking about something that can really provide a whole new level of capability in a wireless product. Now, some of you in the audience might not be familiar with laser radio. Raise your hand if you're not familiar with laser radio. Okay, I see a couple. So let's take a slide or two for me to explain to you exactly what that is. Laser radio is a combined technology. So it's actually combined between advanced optics and millimeter wave. The advanced optics portion is from some technology that AOptix built in the mid-2000s through some work we did with the US military, way before you had Facebook drones or Google balloons flying around. AOptix was actually working with the US military to create a wireless network in the sky, so multiple airborne platforms, all communicating to each other using infrared optics, but through the air instead of through a glass fiber. We've combined that with a tightly steered version of millimeter wave. So you combine these two together. This is where the name laser radio comes from. Laser refers to the advanced optics portion. Radio refers to the millimeter wave radio portion of the technology. But what really makes it unique is how those two things are combined. So to give you a visual of what we're talking about, this is a point-to-point line-of-sight product. So it's basically a wireless replacement for fiber. Any place that you would connect 2 points, you could connect with these. It's, the current version is a 2 gigabit product. And at the transmit side, you send that 2 gigs redundant data streams across both sides. So millimeter wave, advanced optics side are both sending the 2 gigs. Now at the receive side, you actually take those two data streams and merge them together in real time using something we call dynamic packet resourcing. And this allows you to give an output data stream that's far more robust than you could get from any of the wireless technologies by themselves. So now you've got 2 gigabits going across up to 8 kilometers in this space, and that's what basically gives you laser radio technology. And it is a multi-gigabit wireless transport for carrier-grade networks, where it's usually deployed today is in the mobile backhaul space, specifically for macro cell backhaul. Just to give you a little bit of context about where laser radio is in the real world today, over the last year, we've had a lot of recognition for the disruptive nature of the technology in the macro cell backhaul space. We were identified as a Gartner 2015 Cool Vendor in the communication service provider space. We've been on MIT Technology Review, had a feature in the Wall Street Journal, many other publications. Been identified by Fierce as the Fierce 15 and Fierce Innovation Awards winner. And laser radio has been deployed in 7 countries over 4 continents, including major tier 1 carriers, one here in the US and also over abroad in the Middle East as well as in Malaysia. And we have the lowest cost per gigabit, laser radio does, for macro cell backhaul. And if you have any interest in how this technology plays into the macro cell backhaul space, OBM did a white paper earlier this year that goes through the cost breakdown of laser radio versus fiber versus millimeter wave and microwave. It's a very interesting paper if you have a chance to take a look. And as I mentioned, we recently proved out the component prototypes for our future product. So now we have a 2 gig product, and in the future there'll be a 10 gig and a 40 gig product as well. Right now we're looking to have those out towards the end of 2016. So this gives you a little bit of an idea of what laser radio is and where it's already deployed. So let's get back to the key topic at hand, evaluating mobile backhaul technologies. So there's a couple of things that you really need to focus on when you start talking about backhaul technologies. And those come down to two groups, technology decisions and business decisions. In the technology decisions space, it's really about capacity, distance, and availability. And there's that one little spot in the middle there where you actually get everything you need for your particular backhaul application. The problem is that capacity, distance, and availability are sometimes at odds with each other. When we're talking about something like a millimeter wave, a traditional millimeter wave product, for example, if you go to 1 or 2 gig product, maybe you're using a higher modulation scheme to be able to get more capacity out of it, you're probably going to have to compromise a bit on the distance or availability aspect of it. If you go with a traditional microwave solution, you might get longer distance, but now we're looking at, instead of a gig product, we're looking at a 50 meg or 100 meg product. So when we're looking at getting the perfect combination of these three things, particularly in macro cell backhaul and for 5G, as the requirements for macro cell backhaul get into the gig and above, you don't have, there's only a few wireless solutions that actually can provide macro cell backhaul distances with multi-gigabit capacity and very great availability, and laser radio is one of those products. There's also business decisions that need to be taken into consideration when you're thinking about what you're going to use in a backhaul deployment. And it comes down to deployment speed, flexibility, and cost. Now, deployment speed is really important. If it takes you a year to put in a new fiber, you're going to lose revenue and you're going to lose access to customers that you really need to connect to. So when you have a deployment capability that allows you to go out to a new site in a short amount of time, that's a real advantage. In terms of flexibility, it depends on where can you actually deploy a product. Is there a monopole or a tower or a building? Are you going to have to deal with a large amount of twist and sway? There's a lot of the wireless products that can be severely impacted by more than a couple of degrees of twist and sway on a particular monopole or tower. And cost. Cost is always incredibly important. Yes, I'm wrapping up right now. Cost is always incredibly important. So all of these decisions together are all required to be able to evaluate your mobile backhaul technologies. So if we think about how this will play into the future networks in 5G when we have all these great capacity requirements, then we have to ask ourselves, well, what can we do today to actually prepare for 5G backhaul? Well, what we can do is create adaptable infrastructure that gives us scalable capacity, that has the ability to expand as our needs expand. And the thing that we know is that the growth need will be exponential. It's not going to be linear. It's going to be up and to the right, the way we wish all our balance sheets would be. And so to get there, we really need to be looking at what we can put in the field today that will allow us to prepare for that. If we build today's network infrastructure with 5G in mind, and we incorporate cutting-edge technologies like laser radio and some of the other ones that we've heard about today in this conference, then we can make an adaptable infrastructure that will allow us to make our visions of 2020 with the Internet of Things being driven by 5G a reality.